based on the question, the situation given was supposedly Along wants to send a secret message to Busu, and both of them agree to use the following coding method. The set of numbers are written in a metric of dimension 4x4 as follows. Since Busu is given three different set of matrices K1, K2 and K3, we are required to help Busu to decide which the given key will decrypt the secret message sent by Along.
For the first task, we need to find the inverse of K1 using a join method. Then decrypt the message using the inverse. Is it correct message? If the answer is no, then explain why not.
The first part is we are going to find the adjoint of matrix K.
For matrix K3, we decided to use adjoint methods. First, we need to find the minor, the cofactors, and the determinant for this matrix.
The thing we need to do is reduce the matrix to 2x2 matrix and find all the elements for each row and column. So after getting all the elements for each row and column, now we already obtained the minor for the matrix. After obtaining the minor of the matrix, we need to change it to cofactor by applying the rule of alternating the positive and negative sign of all the elements in each row and column. So we will get the cofactor of the matrix. After getting the 2x2 matrix form, so we can find the determinant of matrix K, just like what we do in solving the 3x3 matrix. And there we go, as we got -91 as the determinant of matrix K1. So the final part in finding the inverse of matrix K is substituting the determinant and adjoint that we obtained from the past procedures.
For the second task, we need to find the inverse of K2 using ERO method and decrypt the message using the inverse. Is it correct message? If the answer is no, then explain why not.
There are three procedures that we can use to find the inverse of matrix by using ERO method, which are multiplying a row by a non-zero scalar, interchanging any two rows, and replacing a row by the sum of itself and a multiple of another row. So the first step is you have to form an augmented matrix which consists of matrix and identity. So now we are required to perform an elementary row operations until the identity matrix appear on the left of vertical line. So as you can see in the diagram, we use the second step, which is interchanging any two rows, to gain 1 in row 1 and column 1. So now what we need to do is change the second, the third and the fourth in the first column into 0. As you can see in the diagram, we have already gained the first column, which is 1 0 0 0. So we need to proceed to the next step until we gain the identity matrix that will be appear on the left side. So after performing all the elementary row operation, we have gained the identity matrix as shown. As we can see now, we are unable to complete the steps as the fourth column in the fourth row equals to 0. This is because 0 cannot be changed into 1 by using any method told earlier. Therefore, this is the final answer.
For the last task, we need to find the inverse of K3 using either methods and decrypt the message using the inverse. Is it the correct message? If the answer is no, then explain why.
As for now, we are going to find the inverse of K3. Since we choose to use adjoint method, then the procedure is exactly the same as what we did in finding the inverse of K1, which is we need to find the minor, the cofactor and the determinant. finding all the requirements, the inverse matrix of K3 is then multiplied with matrix P. After getting the inverse, as shown in the diagram, the number is then arranged alphabetically, and finally, we gain the message code, which is written as asasi pertanyaan. Once we gain the inverse of K1, K2, and K3, it means that we had completed the task. Now, we are required to answer the questions below. Based on question 1, obtain 3 different messages from 3 keys given above if possible. We succeed to obtain only message in K3, which is asasi pertanyaan. Among these 3 messages, K3 is the correct answer as it satisfies the coding number. The numbers matrix in K3 was transformed in alphabet arrangement, such as below. Based on question 3, number in matrices that we gain in K1 and K2 does not satisfy the coding method. There were negative values. Therefore, the values cannot be transformed in alphabet arrangement.